Hello, students. Welcome to the Shala. So, here in our language development. So, you all know we have completed a Linux system programming course and we have also got knowledge on basic Linux kernel development, right? So, where we have learned about first in the first course, we have completed about different concepts of system programming like process, threads, inter-process communication, everything, right? We have seen different system calls and everything. And in kernel programming, we have seen what is a kernel, how to create a kernel modules, inserting kernel module, removing kernel modules, and mod probe, all these things. That is to give you a basic idea about what are kernel modules. Okay, so from now on, we are in the advanced Linux development course, right? So from here on, we will be concentrating more on the Linux kernel development. In the previous video, I have given you introduction about kernel, what is user space, kernel space, how user space and kernel space will communicate with each other, what are different device drivers available, why we need device drivers, how they classify the devices, all these things we have discussed, right? So now this is the next part in our development series. So in this lecture, I will be explaining you about what is a Linux kernel, what is the versioning of Linux kernel, architecture of Linux kernel, how to clone a Linux kernel in our PC, and how we can actually compile the kernel, and all these things we will be discussing in this lecture. Okay, so let's begin. Before starting, what we can do is let's keep few things handy. The one is Excel. Yeah, this is one major website that we will be using. Okay, so where a complete Linux kernel source code will be present, and another is kernel.org. Let's keep these two things open and we will proceed further with our lecture. Okay, now first, what is Linux kernel versioning? Okay, so whenever first we know what is Linux kernel, right? It will be releasing by actually maintained from Linux kernel foundation, and they will be releasing all these things, right? So whenever they are releasing a new version of the kernel, they will be having some kind of versioning system to denote what version is actually being released. Okay, just how our softwares will be having version 1.1, 1.2, right? Similarly, Linux will also have something like versioning system which they will follow when releasing a Linux kernel. Okay, so this will actually help us to understand what kernel we are using, what are the updates from previous kernel, what patches got pushed into this kernel, what are the different changes that have been made in this particular version of the kernel. To keep all these things in a track, they will be following a versioning system to release a Linux kernels. Okay, so Linux kernels will be in this format. I mean, they will be generally following a format which is major number, minor number, and patch revision, like that. Major number represents when like a completely set of new features have been added, like they are adding some new implementations and they are releasing the kernel, so they will upgrade the major version of the kernel. In minor version, what they will be doing, I mean, for example, some major version has come with version 6. In that, they will be updating the kernel patches, right? Whenever new developers submit this patches, they will be picking and upgrading it to, actually, they will be upgrading the Linux kernel, right? So they will come under minor version. And then patch and revisions means if anything, any bugs are there, anyone submitted some patches on the existing features, or anything need to be revised on that particular commits or anything, they will be updating those things with the patch or revision. Okay, for example, if you see here, this is the kernel source code. So we will clone it in our local PC. For now, for understanding, remember this one. This is our Linux kernel source code. If you see here, left side, these are all the major versions. Initially, it started from version 0, but actually from version 1, things started picking up. So currently, we are in the kernel version 7. Okay. For example, if you see here, version 7, this is the major number. In that version 7, 7.0, 7.1, these are the minor numbers. Okay, if you see something related to RC, it's some release things. So let's concentrate on the stable versions. Okay, so for example, if you take here 7.0 and 7.0, there are different things again. 7.0 major number, minor number, and the patch and the revision number. In 7.0, we have got till 5 revisions. Okay, if I click here, wait, it's loading actually. Ah, So your entire kernel source code will be sitting here. This is how your kernel is organized into directory structure. Okay. If you want to see, if you are particular about kernel version 6, you can go to kernel version 6. If you are particular about minor number 19, till 14, you have the versions, right? You can go to anything. And you can check the code. I will show you what changes got committed, what are the changes between this version and that version. So these are the things. So every major version or the minor version kernel will be updated here. You can see this particular directories. You can see all the code related to things. We will explore these directories in next part of the lecture. For now, you get hands-on with this particular website. You can see everything. You can see net. If you come to here, net. And if you see, we are already developing some Bluetooth stack and kernel things, right? In kernel, we will be hitting over here and we will be changing all these HCI, SCO, ESCO, these things we have discussed in our Bluetooth kernel development, right? So, and if you are someone who is interested in DNS or 802, these kind of things, this personal area network, these kind of things, your code will be sitting over here. Like that, a kernel code is organized into directories. Say all security related things will be here, architecture information will be over here, libraries, and all these things. Okay. We will explain what are these things and everything. Next, if you see this website, see 7.1 RC2, 7.1 RC2 is currently going on. But in case if you want to see 7.2, I mean, if you click here, view diff, these are all the commits that has been pushed to this particular version. So you can see whoever did any changes, you can see it over here. So some person actually did changes to this particular arc or signal.c. Okay, that is his changes. So this is the commit ID, and someone else did in the driver, someone did in the GPU, and these are the changes actually they have pushed it. So whenever if you want to see what are the changes that has been pushed to this particular version, you can just click on the view diff. Okay, and also this is the patch information completely, and change log. If you click which author has pushed these changes, what is the commit ID, when did he push, and what is the commit message, everything you can see it over here. He has worked something related to IPv6, so he has pushed that changes. Okay, similarly you can see all the related things. Whenever you see here stable, this is the stable version. Whenever you see EOL, it means end of the life, it's been going down. Now, long-term support, LTS, means they are planning to support for long-term. Okay, this is how a Linux source codes are divided into things. And whenever you click on changelog, you will see what is the commit it has been picked. And there are multiple information. If you want to download the patch, you can just click on the patch. And if you click here, you can download this particular patch tarball, how you want to download basically. Okay, now one more thing here, pub. Just click on this one. You will come here. Ours is a Linux. And again, different things will be there, Bluetooth, daemon and everything. Forget about network and these things. We are interested in the kernel. So you will come to here kernel, and here also you can see all the versions. If you are interested in version 7, these are all the things that are going on. Okay. Change log. If you see the change log, see, these are all the actually the commits that has been taken at that particular branch. So this is how you should navigate through website and get the relevant information. Okay, so this is hands-on with all these two websites. Now let's proceed further. So we have discussed major number. I have shown you, right? A major number, minor number, and the revision which is going on. So that is how a Linux kernel version will be happening. Okay, so let's see a practical example. This is, I have downloaded one Linux kernel for showing to you, but let's see what is the default kernel available. Uname -, yeah. So currently, where it is? Yeah, my system is actually running on this particular kernel version. Okay, so you can similarly check what kernel version you are running on. Don't get confused with this one. This I have just installed, I mean synced locally to show you how kernel architecture will be looking like. By default, my kernel is this one. Okay, hope you are clear how to check Linux kernel version also. And here if you see a major number 6, minor number 0, and this is the revision set. Okay, so this is how generally a Linux kernel versioning will be happening. Okay, so you are clear with these things, right? Now, different types of Linux kernel releases. We will have mainline releases or stable releases, long-term support, end of the line, and means some are not suitable for production, but they will be releasing for something. So generally, we will be working on the stable versions, and mainline is actually the main kernel version. Okay, we will be mostly syncing the stable version and proceeding with our course. Okay, this is how we have explored this one also, right? So till now, you know what is a kernel, what is a kernel versioning, a major number, minor number, revision versions, and the websites, how to follow that one, right? So this is how this is the basic tools, I mean, basic things that you need to know before starting Linux kernel development. Okay. Now, okay, we have seen these websites also, and these things also fine. Hmm. Kernel version, major version, minor versions we have studied. Downloading kernel. Yeah. So before downloading kernel, let me tell you one thing. Okay, let's proceed further. Let's go to GitHub. Linux kernel source code. Same thing, what we have seen over there, same thing, it's in the GitHub. You can simply clone the latest tip, actually, your Linux kernel code. Okay, so you can just click on this one and you know, right, Git and everything, you can simply clone the tags and proceed further. So this is how generally Linux is organized. Okay, so now let's proceed further. Yeah, here I have mentioned different steps actually to sync the Linux kernel. Here, this I will share you anyhow. So you can just download the Linux kernel either through tarball. Here I have shown you, right? Tarball or PGP, whatever you are comfortable with, basically. Because how convenient you are in your Linux trees, you can simply download and go with that one and just install the things where it is. Yeah, so you can download however you want, whichever version you follow. You can directly get it from GitHub or anything, and you can simply extract. If you are comfortable in Git, you can get it through Git clone, and you will get. And if you want to clone to any specific branch, then you can check out like this, and you can clone that particular branch, and you can follow these steps. Okay, now I will show the if you do this thing, entire kernel will be I mean synced into your local setup. That is one process. But assume here, yeah, you are already in, for example, like 6.12.87. Okay, and you want to upgrade to some next version or anything. Okay, so what you can do is simply you can download the patch and apply to your particular, I mean, once you download this particular patch, just go to your GitHub. I mean, you have cloned the kernel, right? Already existing kernel. Just apply this patch over there. You might get some merge conflicts or anything. Just resolve that one, and actually you will be moving to the latest version of the kernel. Means if you are good in Git, you will be handling these things. In case if you are not in good and you are still starting exploring, this is a simple approach. Just git clone the kernel, and you will be having the kernel in your system. Because in the first video, I have shown you how to run this kernel in user mode also, right? So we will use that also. So this is the process how you will be downloading your kernel or patches. Okay, got patches got downloaded. Okay, let it be. No worries. Okay. So this is how you can download your patches and you can apply. You have seen everything, right? Which patch you want to download and everything. You can proceed further. Yeah, kernel and this source directories we will study in some other time. Okay, kernel.org, whatever you want, you can actually proceed. Gitkernel.org. If you see, yeah, we came to the same. This repositories kernel will be maintaining. Okay, so this also you are comfortable now. Linux kernel people, if you see here, it's okay. Different things who will be maintaining. Let's get deeper into those things as of now. So version 6, if you want, change log, stable reviews, and everything you can find it over here. If you want entire thing, if you want 6.1, you can just get this gz file and you can extract in your Linux PC. If you already have something, you will be having something called as patch files here. Yeah. For example, if you are currently using 6.10 and you want to upgrade to 6.11, you can add this patch and you can upgrade. Like that you can do. No need to download entire kernel. Okay, this is how actually a Linux kernel versioning is. So now you are comfortable with what is Linux kernel, kernel versioning, major number, minor number, patches, how to sync the Linux kernel and everything, right? So you can, I don't suggest patches, and if you are completely new to Linux or Git, don't get confused. Who are experienced, they will handle it. If you're also beginner, don't worry, you can simply clone the Linux kernel. I have given you command over here, git clone. Okay. Yeah, you can simply follow this command and the latest version of the Linux will be cloned into your system. Okay, that is how Linux kernel will be downloaded. Okay, now let's see about Linux kernel directories. So here, this is the Linux kernel which I have synced. Okay, see, these are all the different directories that are available in my Linux kernel. Okay, so let's see what they are actually. First, architecture. ARCH. Do we have? Yes, ARCH. If we go into ARCH, CD, ARCH, architecture. Here you will be seeing different components that are related to architectures of the boards, RISC-V or x86, like that, the ARM64, ARM. This we will be using actually, we will be developing some embedded products, right, in upcoming lectures. So then we will explore more about that. For now, you understand ARC will contain all the information related to architecture, because each CPU architecture has its own boot configurations, memory management, and interrupt handling techniques, right? So this ARC particular directory, architecture specific code, will contain subdirectories related to different architectures of x86, ARM, ARM64, and they will actually help for device booting and configuration things. So that is the purpose of architecture. Next, drivers. Let's see drivers. What will be there in that particular drive code? CD drivers. So here you can see different drivers, I2C, I3C, and there might be SPI also. Okay, it's not there, no worries. RTC, soundwire, when you are working on audio development, soundwire and pulse audio, these things will be coming into picture. SPI drivers, I2C, I3C drivers, like that. You have like different drivers actually, all driver related information will be over here. Okay, so whenever you are working some real-time clocks, regulator information, pulse width modulation, whatever. So HID, all these things. So whenever you're working something related to driver related things of your kernel, this will be your first point of directory to search. Okay, so drivers will be having all the information related to drivers. Okay, that is the thing. Next, FS. Let's see FS. FS basically stands for file system. Okay, so FS. There are different file systems available over here. What you are aware of mostly. Let me give you an example. If you go to file system, ext4 or exFAT, all these things you are available. You are known, right? What is a file system basically? So file system related information will be over here. ext4, exFAT, ext4, FAT, F2FS. See, basically these are the file systems. How actually files are organized and these things. Overlays, you will understand these overlays and everything once we get deeper into this development. For now, FS is basically file system related directory. You can find information about the file systems. Okay, now kernel. Here actually your core kernel code will be sitting over here. Your schedulers, timers, interrupt request, namespaces, everything. Kernel. Yeah, wait. ls. See all the interrupt requests or your C groups, you will see what are the C groups and everything, DMA related information, modules information, print K. If you are working related to anything related to kernel, you will see over here. panic information, cal sims we have studied, right? These things, all these things you will be seeing over here in your kernel. Okay, so this is the requirement of our kernel directory. Now, memory management. This is one more directory. Okay, cd all your memory management related information will be happening over here. You will have specific main file, and all your memory management things will be happening over here. So when you are working in the memory management area, this will be your first area of contact. Okay, here I'm just giving an overview of each and every directory. When we are going into code development, actually we will see what are all these things. Okay, now network driver, here we will be working more. Okay, I will show you. Here, if you see, you have network drivers related to different things, 6WPAN and 802. You'll also see Bluetooth, yeah, Bluetooth. So actually, these are different networking things that you will be using, 802.1.154, and this one IPv4, IPv6, all these things, all network related things will be sitting over here. This is actually, they will help for, I mean, they will be giving your sockets actually when you are writing socket programming. So yeah, this is how generally your network drivers will be there, network path basically. So we will be working more extensively on this network path. Okay, rest of the things maybe I will show you, but network path and especially Bluetooth and Wi-Fi drivers will be our main point of contact. Okay, now we have clear, right? Net include. Here you will see all the header files that are publicly available to interact with the kernel. cd include all your header files what you are looking for related to will be available over here. If you see here, ls and the cd bluetooth and HCI code.h, HCI, these things actually you will be seeing over here. This actually we are writing, right? Bluetooth development, our Bluetooth kernel development course. So we are using these things only, HCI core and SCO, ISO, all these things. Basically, they will interact with the kernel. I mean, the actual hardware. Means from user space, we will be accessing these system calls and then we will be interacting with the Linux kernel, and kernel will actually hit the Bluetooth hardware in our system. This is the flow. So this is what we are actually working, this socket.h or anything, right? So this is how kernel code is organized for networks. And I'm talking about include directories. So if you see here, I'll show you one thing, HCI. Sorry, yaar. Yeah. See, this is our HCI socket.h, right? We have seen AF socket and these things, how they will be coming, right? So this is how kernel network drivers are organized. So this is what we will use for our actually socket development in Bluetooth. Similarly, we will be having for other things also. We are mainly concentrated on this Bluetooth and Wi-Fi things. Okay. So we will explore in that classes how we will be using this network drivers. Okay. So we will mostly work on network drivers. That is one part. Now, include we are clear. Lib. Basically libraries. This is for libraries actually. CD, CD and lib. All libraries what you are looking for actually will be stored over here. Basically this information actually like kernel will have its own string functions and cyclic redundancy check and these things hash tables. So means the libraries basically which are common that are used across the kernel. Okay, so means there will be some modules which are shared across different components of the kernel. So such kind of things will be placed in this particular lib directory. Okay, so this is the importance of lib. Now init. So you all know, right? Okay. If you don't know, start kernel is the first C function that kernel calls after the boot. So all init related information will be present here. cd init, cd init and cd init vi main.c kernel Okay, no worries. Where it is? Start kernel. This is in main.c. This is the first place where your kernel will be starting after booting. When we are actually developing kernel, I will show you how IRQs and these things will be happening. Boot configurations and CPU things will be handling. So for now, as an understanding, in init directory, you will be having the first, I mean, different files that are responsible for kernel initialization. In that, void start kernel is the first part where you will hit of your kernel initialization. Okay. Now, similarly, security. It's okay. Security, crypto, and all these things are basically used for your crypto, basically some cryptographic functions, basically for your kernel security. Those that directory will be helping. CD crypto, if you see, yeah, these are some actually the cryptographic techniques, ECDH helper functions and elliptic curve cryptography. Basically, these are some cryptographic techniques that we will be using for our security purpose in Linux. So those are all defined over here. Okay, now sound drivers. This also we will be exploring. Okay, CD. See, here you will have something like ALSA drivers and these things. Sound drivers. Okay. So any your audio or Bluetooth audio, if anything need to work, basically it should be able to produce the sound, right? So all the sound related information will be happening over here. Any sound related things, any configuration, any drivers or anything will be happening over here. This is if you are working in audio driver development, this is the main place you should concentrate more. We will see audio, video, V4L2 drivers and these things also I will explain in upcoming lectures. For now, understand this particular directory is responsible for your sound. Either you connect through audio, your headphone jack or slim bus, or I mean basically the sound wire what we have seen, all these things will be there, right? So they will be handled over here. Basically, this is the first point of contact when you're working in your audio driver development at kernel level. Okay. Now, yeah, sound and virtualization. It's okay. Rust language support is also added, but we will not explore that much related to that in our course. Yeah, some Rust related things are there, but actually we will not touch any part of Rust in this kernel development course. Yeah, two things you should, yeah, these are the directories. I hope you have got an idea what these directories are meant for. So here the main concentration for us is net, architecture, drivers, file system, kernel, and lib and init. Okay, but our courses will actually be working on net and sound and some part of graphics. That's a different story, but net and sound are our top priority. Okay, so we will concentrate more, and kernel is obviously kernel and drivers we will touch, but what most of the development that we do will depend on net and sound, network drivers and audio driver development. Okay, now, yeah, I hope you are clear with these things. And one more good thing about this kernel is the documentation. So any doubt you have related to kernel, you will have this documentation. You can refer anything related to anything. So if you are, I mean, if you want some information about I2C bus or anything, you will have that information placed over here. And similarly, if you want, these are Rust things, ignore. So basically documentation in Linux kernel will give you complete information of what you want, what you are actually looking for. If you have any doubt about this, I mean, they have added some implementations and these things, but you don't know what it is. So you can actually refer this documentation or application binary interface. This is also one thing. It will give you actually what they are, what they do. So when you are free, I mean, if you have some, you should spend some time understanding this documentation. Yes, things are available online, but reading them will actually give you an idea like what it is and these things. Okay, now kconfig, this is important. Okay, so let's explore. So you please concentrate more on this documentation thing. No. K build. So Our Linux is completely dependent on these three things: kbuild, kconfig, and one make file will be there. So generally, this is the point where everything will be starting. So we will be using this kbuild architecture for compiling our loading our modules and everything. Okay, so if you see kbuild, it will be internally picking some more scripts and these things basically. So whenever you are building any kernel, this kbuild, kconfig, and your makefile, this is where the main things are actually defined, how to pick the things and everything. If you want, I will show you one thing. So let's come back. This is the kernel which I have synced. I have shown you, right, the git clone command. So I have synced this one. Means I synced it long back, so it was showing this version, but concept will be same. Here, make menu config. If I do like this, see, yeah, you are seeing these things, right? How do you think here you will have option to enable or disable any requirements based on these things. So when you saw the initial issues, right? When we are not able to load the kernel modules, then we have enabled this virtualization. Some things we did and ensured that kernel is modules are actually getting loaded, right? So basically, this will give you an option to what modules you want to include, what to ignore, and these kind of things. And some modules, some options will be like tri-state. Either you can enable, disable, or you can compile, but later on you can insert it like a module like that. You will be having different options. So all these things are getting picked up from your kbuild and kconfig configuration. For example, if you see here, you will see something like Linux x86 kernel configuration, right? So from where do you think it get picked up? From here. So that means kconfig got compiled and it is running. So the top line should be your Linux architecture, kernel version, and kernel configuration. So we are seeing the same thing. Linux, the architecture, kernel that I am using, and the kernel configuration. So all your things, all the things that you are building in your Linux will be starting from your kbuild, kconfig, and make files. Okay. So now let's exit. We have nothing to do with this thing. Done. Not needed for us at this moment. Don't disturb anything you in your kernel, but that is how you will be seeing. So all these make files or kbuild or kconfig, these are the main things that our system kernel will be using to build the modules or to config anything. This is the point of contact. Okay, so this is how things will be working, and you will have some, yeah, in kconfig again it will include some more things, and internally they will get some more options. So that is how a complete make of this Linux kernel is made. Okay, that is one more concept, kconfig and these things. Yeah, config, actual config, these things we have studied, but in case if you want, you can look at this one. Yeah, so same thing which I am mentioning, actually all these things we have discussed. Yeah, I hope you are convenient with Linux. In case if you are not sure how to use, these are the shortcuts that we will be using. Okay, config file, vi.config. We did not build. So, but in case the, or see there in case, I mean, here we have enable, disable, and all these things, right? Final config file will be reflecting them. Once you make the changes and compile the kernel, you will see all those changes getting reflected in the vi.config file. Okay, so now important step. I already compiled, but in case as you are the first time user, first to recompile the kernel, you should have some basic build dependencies, we will call it. These are required for building our Linux systems. So you need to install them. After that one, you can just follow, you can extract the, I mean, you will, first step is actually to install these build dependencies. Then you can get this Linux source file and you can extract that one, and you can actually go into that particular Linux directory, like just how I did into this one. I have taken release version. You can prefer any stable version as of your wish. Then first you need to configure the kernel. If you recommend, means if you are not willing to do any changes, that is also fine. In case if you want to do any changes, that also fine. Okay. Then you can start from the scratch. The make menu config which I gave, you can press enter and it will compile. In case if you only want some minimal config, it means you did some changes related to your hardware, then you can simply give this command and compile. Okay, now here is the actual compilation. Just you give this make command, it will compile your entire kernel. Okay. After this entire kernel compilation, you will see this VM Linux system map, basically your kernel symbol table. What symbol table will give you how these symbols resolved and their addresses and all these things. And here you will be having your bootable kernel image and everything. So once you compile ls, here if you see VM Linux. What is VM Linux? VM Linux is basically your uncompressed ELF file. This is what we have used to run this kernel in the user Linux mode, right? So this is kind of a ELF function. Okay, now system map. System map. If you want, I will show you system map. System map. So each, kernel symbols are resolved and their addresses have been added here. So maybe when you are debugging in the core kernel level, you should actually refer some map files and everything to understand the address and these things. Okay. So this is how once you compile the kernel, these are the files that you will be seeing. Next. Okay. Now kernel image compilation is done. Now, if kernel modules means, see in make menu config, you have selected for some options as M, right? Means you want to compile them as modules basically, right? So in that option, you can run this particular command and you can give the command. So those particular things will be triggered as modules. Okay. And after generating these modules, if you want to install that particular module, you can give this command. But as a beginner, just clone the kernel and give this command. This is enough for us now. Don't get much deeper, but I am explaining you these things so you will understand the things that these things exist. That is the only intention. Okay. So that is how you should actually make the kernel, and you can build the kernel modules and these things. Okay. So that is enough for now. Bootloader and these things I will explain you while actually we are compiling the kernel. Okay. So these are some actually quick commands which you can use either to check your kernel version or to compile the kernel to make the module and these kind of things. And here I have attached few resources which will actually help you to understand the things. Okay, so that is the concept behind Linux kernel versioning, installing the kernel and compiling the kernel and installing the modules. I hope you are clear with these things. I did not show you all this compilation and these things because actually in our kernel development course, we have actually given these steps. As video length will become more, I did not show you. But if you follow this guide, it should be simple. Okay. Hope you have learned something related to kernel things. From next lecture, we will explore more about these directories. We will start writing kernel modules, device drivers, and everything. Okay. That's all for this class. Thank you.